Hello everyone, in this part we're going to introduce the weighted signal propagation interference mitigation methods. And we have listed some methods. First is appropriate channel planning, appropriate power adjustment, appropriate site selection, full use of natural barriers, use of the coverage mode with multiple antennas and local power, use of the 5G band, of course, computed with the 2.4 gigahertz band. 5G band is seldomly affected by other signals. Okay, and last is appropriate antenna technologies. Since we have known these methods, so let's see how to appropriately design, for example, the channel we use. Okay, according to IEEE 802.11b and G, the theoretical operating frequency bandwidth is 83.5 MHz, which is divided into 13 subchannels, each with 22 MHz bandwidth. There are 3 subchannels that do not interfere with each other, and is what you can see in this figure: 1, 6, and 11, which is marked with red in the figure. Although channels used by APs do not interfere with each other, they also affect each other because the spurious emission level of WLAN is 2.4 dBm and 22 MHz. Therefore, when multiple APs exist, channels used by adjacent APs must be more than 5 channels apart, and their center frequency must be 25 MHz apart. The coverage of adjacent APs needs to be loss overlapped to prevent the reduction of the overall capacity. Okay, so let's see. Here is showing us some examples. And first is inappropriate 2D channel design. And obviously, we can find that in this figure, the radius in the same channel, for example, in channel 11, they are close to each other. And the radius in channel 6 are close to each other. So it would cause interference. Right. The appropriate design is showing in this figure, in the second figure. In this figure, you cannot find any signals in the same channel close to each other. Right. For example, 6, 11, 1, 11, 1, 11. Right. So there's no signals in the same channel close to each other. In this way, we can prevent the interference in the network. Okay, and next is appropriate 3D channels. For example, in a building, we have 3 floors, and at the first floor, we have channel 1, channel 6, channel 11. And on the second floor, you can see channel 6, channel 11, channel 1. And on the third floor, channel 11, channel 1, channel 6. So even in a 3D network, appropriate channel design can prevent the interference. Okay, so this is about the channel planning. And even we have finished the appropriate channel planning, as you can see in this figure, no signals in the same channel are close to each other, but inappropriate power design can also cause interference. For example, the power of AP is too high. It causes that the signals in channel 1, you can see here, is affected to each other. Right? It will cause interference. This is called appropriate channel design, while inappropriate power design. Okay, to solve this problem, we should adjust the power, right? And to make sure that the signals in the same channel will not affect each other. You can see here now, the signals in channel 1 do not affect each other anymore, right? So by adjusting the power, we can solve this problem. Okay, and next is appropriate site selection. Because in our daily life, there were a lot of possible interference resources. For example, the strong interference resources in the first figure, or if it's an indoor project, a microwave oven, right, will also cause some interference. So when we plan the antennas or when we plan the APs, we should find the station which is away from the strong interference source. And the position we plan the APs or the antennas should have a broad view. You can see here, here are some antennas, right? It's at a broad view, and the users or the STAs inside this coverage can receive the signals directly from the antenna, right? Will not be affected by other obstacles. Okay, this is about how to improve the network and how to prevent the interference in the network. And about this part, here is a question. Which of the following choices could cause interference? A. Inappropriate channel planning. B. Inappropriate radio power. C. Inappropriate site selection. D. Inappropriate AP local power. Which of them do you think that could cause interference in the network? Actually, from my point of view, all of them could cause interference, right? So during the network optimization, you should take all these points into consideration. Okay, so that's all for this part.